thanks for watching, and today I will prove the celebrated L'Hopital's rule, and you'll see the proof is really beautiful. It brings us through some analysis, but it's one of the proofs where you have to be extra careful about where your constants are, and there's be lots of pain, lots of epsilons, but in the end you're left with a very neat epsilon at the end. So, and it also leads us to a generalization of the mean value theorem, which is also super cool. So I really can't wait to start it. But first of all, just one thing about L'Hopital's rule. L'Hopital didn't actually come up with it. It was supposed to be Bernoulli's rule. But L'Hopital at that time had stuff mathematicians don't really have, lots of money. So he literally bought, L'Hopital's rule. So I guess money can do everything, okay? But anyway, we have our happiness. That's all that matters. So, remember, what does L'Hopital rule say? So, a lot of calculus students, they just write blindly, limit x goes to a, f of x over g of x equals to limit x goes to a of f prime of x over g prime of x equals to L. You find that, it's easy, the limit equals to L. But what does that really mean? It means that if this limit exists and equals to L, then in fact the original limit exists and equals to L. So let me write that down in more detail. So theorem. So suppose f and g are differentiable. And let's just use the rule like 0 over 0. Because the rule infinity over infinity is just an adaptation of this proof. So if f and g are differentiable and the limit as x goes to a of f of x equals to 0, limit x goes to a of g of x equals to 0. In other words, again, suppose you have the case 0 over 0, and suppose that the ratio of the derivatives, x goes to a of f prime of x over g prime of x equals to L, then we have that the original limit, f of x over g of x, equals to L. Again, this is it's funny because when calculus student does a proof like that, solves a problem, they actually go through that whole process unconsciously, but they don't really think about that. But again, this is the statement of L'Hopital's rule, and in this proof, again, otherwise it becomes more complicated. Let's just assume that g and g prime, they're not 0. Like never 0 or something. And as I said, it's a really nice analysis proof. So if you like analysis, this is for you. So step 1. It's so nice. We want to show this, right? That the limit of f of x divided by g of x is L. So using epsilons and deltas, what does that mean? So we'll show limit x goes to a of f of x over g of x equals to L. So let epsilon be positive. And we want to find delta positive such that if x minus a is less than delta, then the ratio f of x over g of x minus L is less than epsilon. Okay, well, so remember, when we show f of x over g of x minus L, if at the end we find epsilon, we're happy. So just remember, epsilon means happiness. So Alright, now let's fix x. Okay, so for now, think of x as a constant, like 2. So Step 2. Fix x and let t is to be announced. T will depend on x and it will be to be announced. And what's the idea? Notice, if you think about this, f prime of x over g prime of x. Well, f prime, think of it as a difference quotient. So think of it as, f of x minus f of t over x minus t, and g of x prime of x is g of x minus g of t over x minus t. And think of f of t and g of t as small. So after this cancellation, we get f of x minus f of t over g of x minus g of t.
Okay. Are you practicing a talk or something?
I'm making a video. But
Oh, sorry.
do you need the room?
Well, so we have this conference going on.
Oh, okay. Yeah.
But we don't need it. We don't need this room. But if anybody comes here who
Yeah.
seems like they're from the conference looking for something, just send them up to 420.
Okay,
That's
okay.
where we're having people congregate.
Okay, sounds good.
Yeah.
Good. Yeah.
Cool. All right. Good board work.
Okay,
Good
thank
luck
you.
with the layout.
Perfect.
Okay. Yeah, I see.
Alright, then what we get is that f of x minus f of t divided by g of x minus g of t, which sort of I just want to motivate why we need that ratio and what follows. So, remember what we're focused on. F of x over g of x minus L. We want to show this is small. We want to show this is less than epsilon. And now, this is a nice math trick that appears over and over again in analysis. And I just want to say, if you're ever stuck in analysis, this is probably why, because you forgot that trick. Namely, we want to take this quantity and add and subtract that quantity. So minus f of x minus f of t over g of x minus g of t, and we want to add that back to make it legit. F of t over g of x minus g of t minus L. So think of it as a reverse cancellation. If you cancel that out, then you do get that it's equals to f of x over g of x minus L. Okay, good. So it's kind of weird because we took something easy and made it horribly complicated. And in fact, one of the things about analysis, we want to show this is less than epsilon. So let's estimate it. So by the triangle inequality, this is less than or equal to f of x over g of x minus f of x minus f of t over g of x minus g of t. Absolute value, parentheses, plus f of x minus f of t over g of x minus g of t minus L. So we're left with two terms. And for the next half an hour or so, we will study those two terms. Let's call it A and let's call it B. And notice we still don't know what t is. So far everything works with general t. And again, remember our goal is to get an epsilon at the end. So we want to show that those terms are small. Which again, it makes sense. Remember, but later, this will be small and this will be small. So this whole difference should be small. And this is sort of like the derivatives, and we know that the derivatives, they go to L. So we're good. All right, so step 3. Study of A. Remember, A is that term here, so f of x over g of x minus f of x minus f of t over g of x minus g of t. Okay, so this is a difference between two ratios. There's nothing else to do than just to put it on a common denominator. So this is f of x times g of x minus g of t minus f of x minus f of t times g of x is absolute value over the product, so g of x and g of x minus g of t. I don't know, I'm so excited. It's just, you know, when you see something beautiful, you just like, you want to share it. Like the Mona Lisa or something. Okay, let's expand it out. So we get absolute value f of x, g of x, minus f of x, g of t, minus g of x, f of x, plus g of x, f of t, divided by g of x minus g of t. Now, one nice thing is, and this is why we expanded it out, bang bang, right? F of x, g of x, and g of x, f of x. They cancel out, and you're left with this term, minus f of x, g of t, plus g of x, f of t, over g of x minus g of t. I can't stop laughing because g of t, it reminds me of Giti, and Giti is my cousin's name. Donc Giti, si tu me vois, salut. Okay, I'm from French Switzerland. So, now, the numerator, again, there's nothing really we can do, but remember we want to estimate stuff, so let's just use a very rough triangle inequality. So this is less than absolute value of this plus the absolute value of this. So it's f of x, g of t, plus g of x, f of t, over g of x minus g of t. And this is the part I was a bit stuck on. And to be honest, I did look at the solution because it's not quite obvious. But if you think of this, this is sort of two parts of a foiled expansion. So if you take some polynomial and you expand it out, you get those two terms, but also two other ones that are missing. And in fact, it turns out that polynomial is f of x, not polynomial, but like that foiled out term, f of x plus g of x, f of t plus g of t, divided by g of x over g of x minus g of t. So, notice, if you expand the top out, those are precisely the cross terms. F of x, g of t, g of x, f of t. The other terms, right? F of x, I guess, f of t, g of x, g of t, but they're all positive. So you're just taking this expression and adding more positive terms. Okay. Why do you do that? Again, later, as I said, we'll show that f of t and g of t are small, so those two things will be very small. This will be constant, this will be constant, and we'll see this will always be a constant. So it's sort of, this is the controlling part of the term a, and remember we want to show a is small. So we are in good hands. And by the way, this proof is taken from Puke's Real Analysis book, which is one of my favorite books. So I highly invite you to read it. Okay. Now, this thing, it works for any x in this region, but also for any t. And now I can finally release you of your torture and tell you what t is. So given x, again, x is a constant. Think of it as like 2 or something. Let t be the following. Let t be such that, and maybe let me draw you a little picture, okay? We have this x, we have this a, right? X is very small to a, and we want t to be even closer to a. Like imagine, for example, this is fire. I'm pretty close to the fire, but I'm kind of scared to go. But hey, who says fire says flammable mass? So flammable mass is like, I'm not scared, I will protect you. So this is sort of what's called like the advanced guard or something. So it's a number that's even closer to a, and such that the following is true. Namely, f of t plus g of t. Again, remember those are small. F and g, they go to 0 as t goes to a. And in particular, pick them such that this is smaller than, okay, and don't laugh, g of x squared over 4 f of x plus g of x times epsilon. Okay. Again, how in the world did I pick it? You'll see at the end, it makes the things cancel out. So for example, this will cancel out with this one factor of g will cancel out with this one, and we need some other terms. But again, I want to emphasize, remember that x is fixed. So what this says, it just says, assume that f plus g is smaller than a constant times epsilon. Okay. So think of 3 epsilon, right? And that's fine because remember that f of t and g of t go to 0. So f of t goes to 0 and g of t goes to 0 as t goes to a. That's one of our assumptions. And then we will also choose another condition to be announced. So choose t such that this condition holds and an extra condition will hold, which I'll write down in maybe 5 minutes or so. Okay, once we have that, let's play around with this. So, as I said, a is less or equal to f of x plus g of x, okay, over g of x, and then g of x minus g of t. Okay. Now, this term, hallelujah, it actually appears exactly in this expression. So this expression is less or equal to g of x squared over 4 f of x plus g of x times epsilon. And now again, here's where math is really cool. Lots of terms cancel out. So this term cancels out with this term. One of the factors of g also cancels out. And again, if you didn't know what that constant was, just say pick, t such that this is less than a constant times epsilon, and then at the end you have a constant times epsilon. But it's super interesting because notice also the interplay between x and t. So we really have to judiciously choose our concepts. So in particular, a is less or equal to epsilon over 4 g of x over g of x minus g of t. Okay. And now, that's not bad. Ideally, we'd like some constant. So we have to work a little bit harder, maybe to make this g of t disappear. And ideally also that g of x disappear. And for this, we need a second condition on t. Namely, remember this is small. In particular, we can choose it to be less than g of x over 2. Again, this is a constant. So in other words, make g of t small. And the nice thing is we have some estimate. Here's the cool thing. Usually you want absolute values, you want to use the triangle inequality. You want to show it's less than something. But because you have a reciprocal, you want to show it's greater than something. So you have to use what's called the reverse triangle inequality, which, remember, it just says that absolute value of AB minus B is greater or equal to absolute value of A minus absolute value of B. In particular, this is greater or equal to g of x minus g of t. And now, g of t is less than that, so minus g of t is greater than that. So g of x minus g of x over 2. But that's just g of x over 2. In particular, let's go back to A. A is less or equal to epsilon over 4 g of x. Okay. Now you're taking the reciprocal of this, because you have 1 over that, and so you take 1 over g of x over 2, so 2 over g of x. Look at that. This cancels out, and you're left with epsilon over 2. So an absolute value, A, is less than, in fact, strictly less than epsilon over 2. Not bad, huh? That said, I have some bad news. We've just done half of the work, because now we want to analyze B. But I think B isn't as bad, so we'll see. Okay, A is less than epsilon over 2. If only B were less than epsilon over 2, we can manage that. So I guess in step 4, study of B. And you'll see, this is a video that actually makes you smarter. So we're not only doing analysis, we're proving new stuff too. Because what is B? Remember B, maybe an absolute value, was the difference quotients, right? F of x minus f of t, g of x minus g of t minus L. Okay, and here's the idea. Remember what the mean value theorem says? It says that the top can be written as f prime times x minus t. So by the mean value theorem, this term over this term minus g of t. Well, the top, you can write it as f prime of c times x minus t over g prime, let's say of d, times x minus t. This cancels out, and you're left with f prime of c over g prime of d. And I want to emphasize, it doesn't necessarily give you the same number, right? We know that for some c this is true, and for some other d this is true. What if c is equal to d? So if c equal to d, then we have, right, then we get f prime of c over g prime of c. But remember, if like c goes to a, again, very hand-wavy, if c goes to a, this actually goes to L. Because remember, we've shown that, we assume that f prime over g prime, it goes to L. So, if on one hand c equals to d, and you can let C go to A, then this ratio goes to L. In particular, we can make it less than epsilon over 2. Which requires, again, two outrageous things. First of all, to have the same number in the mean value theorem, and also to let this number go to A. It turns out we can do this. I know, right? It's like wishful thinking that is true. So first of all, can we guarantee that C equals to D? Yes! And this is what's called the ratio mean value theorem. Namely, there exists a C in xt or tx, whichever is, I think in my picture t was less than x, so maybe tx, such that f of x minus f of t over g of x minus g of t equals to f prime of c over g prime of c. In other words, the ratio of the differences can be estimated or is equal to the ratio of the derivatives. Pretty neat. And why is it called ratio mean value theorem? If g is the identity function, then this becomes x minus t, g prime would be 1, and you get f of x minus f of t over x minus t equals to f prime of c. So in fact, the mean value theorem. And let me quickly prove it. It's very, very neat. It's just actually an adaptation of roles. So, proof. Define the following function, phi of s to be, again, everything is fixed, so except for s. So f of x minus f of t, g of s, let me emphasize that, s minus g of x. Okay, I don't know how people come up with those functions, but minus f of x minus g of x minus g of t minus g of t. F of s, so I'm getting scholars, so f of s minus f of x. Yeah. Okay, let's see what's happening. So, what is phi of at x? Well, this becomes g of x minus g of x, which becomes 0. This becomes f of x minus f of x, which becomes 0. So the whole term is 0. And what about at t? This is also super nice. This becomes g of t minus g of x. This becomes f of t minus f of x. And so I believe that the terms then cancel out. Because you get, for example, minus, that. And then, anyway, if you do that, the terms do cancel out. So phi of t equals to 0. And so by role, we get that phi prime of c equals to 0. And what does that mean? Again, for some c in xt. But what is phi prime of s? Remember, everything is a constant except this g, so that is, except s, sorry, it's f of x minus f of t, g prime of s, and then minus g of x minus g of t, and f prime of s. So phi prime of c being equal to 0, what that means is that f of x minus f of t, g prime of c equals to g of x minus g of t, f prime of c. So this whole term would be 0, so this term equals to that term, and then, for example, divide by g prime and divide by g of x minus g of t, and you get that the ratio has to satisfy the mean value theorem-ish property. Wonderful! This was like the last hard step, and now we're almost done. I guess yay or like sad. I mean, don't you want to see more adventures like that? Don't worry, I have more videos. So what do we have? Well, b was equal to f of x minus f of t over g of x minus g of t minus L. Now, by the ratio mean value theorem, that equals to f prime of c over g prime of c minus L. And remember where c, it was, so remember, that was a, and then we had x, and we had t. And so c is squeezed between x and t. So, and remember there was this delta, so this whole distance is delta. And because x minus a is less than delta. So it's kind of a funny story. Remember, that was the flame, that was me being scared, that was like flammable mass, like I'm not too worried, and then black pen, red pen is like squeezed between the two. It's like, Payam, I'll give you also protection. How nice. And Fematica is somewhere, I don't know. Maybe that's Fematica, it's like the... I'm getting crazy. It's like the song that raised upon that. Anyway, so what do we have? Remember that the limit as x goes to a of f prime of x over g prime of x equals to L. And in fact, we haven't chosen our delta yet. We said we want some delta such that this is true. So in fact, because we know this, now we have our delta. So there exists a delta such that if x minus a is less than delta, then f prime of x over g prime of x minus L is less than epsilon over 2. In particular, C satisfies that because we said T is even closer to A and C is between the two. So f prime of C over g prime of C minus L is less than epsilon over 2. And lastly, just a quick conclusion. With that delta, what do we have? F of x over g of x minus L. It's less or equal to the first term A that involved x and t, and the second term with the ratios, we've shown that this is less than epsilon over 2 plus epsilon over 2. And here comes a satisfying moment. This is epsilon. Pretty neat. And therefore, L'Hopital's rule is proven. So, at least in that case. I know, a bit harder than you would have thought maybe, but again, it's just this beautiful excursion into analysis and this little story with like front guards, rear guards. So, kind of cool. And again, all this goes in your head when you use L'Hopital's rule. So, it's not something very obvious. Alright, so if you like this calculus analysis excursion and you want to see more math, please make sure to subscribe to my channel. Thank you very much.